Imagine a future where Earth is no longer salvageable, not in a million years, but within our own century. The climate collapses, oceans rise, entire coastal cities vanish underwater, ecosystems disappear, and humanity, 8 billion of us, is left with a single question: where do we go next? Not Mars, not the Moon. NASA is searching for a true second Earth, Earth 2.0, a world with liquid water, breathable air, and maybe, just maybe, life. And the crazy part? They think they found clues, a tiny signal among millions of stars, a planet light years away but eerily similar to Earth. If it's real, what happens next?
For decades, NASA has been asking one question: are we alone? And if Earth were to fall, could there be another place, another home, waiting out there in the stars? The answer might not be as far-fetched as it seems. Since the launch of the Kepler Space Telescope, we've discovered over 5,000 exoplanets, each wildly different, some burning hot, others frozen in darkness. But a handful of them stand out. Planets that sit in just the right zone, not too close to their star, not too far. Worlds where liquid water could exist, where life, at least in theory, might emerge. Among all of them, Kepler-442b is one of the most promising. It's located 1,200 light-years away in the Lyra constellation. It's about 1.34 times the size of Earth, rocky, and orbits a cool, stable orange dwarf star. That means it likely gets just enough heat to support an atmosphere and surface water. It's not science fiction, it's a real place. A world that may already have clouds, oceans, or something more. A world where life could already exist, or could one day be our future. Kepler-442b has become one of NASA's top candidates in the search for an Earth 2.0. And in today's video, we're going to explore what makes it so special and how we might one day reach it.
So, how did we even find Kepler-442b? The journey starts with one of the most ambitious missions in modern astronomy, NASA's Kepler Space Telescope. Launched in 2009, Kepler had a single goal: to stare at one small patch of the sky and watch for tiny dips in starlight. Every time a planet passes in front of its star, the light dims. Just a bit. It's like spotting the shadow of a grain of sand passing in front of a lighthouse, from 1,000 miles away. But this method, called the transit method, worked. Over 9 years, Kepler observed over 150,000 stars and found thousands of planetary candidates. Among those, Kepler-442b stood out. Its orbit lasts 112 days, meaning it's close enough to be warm but not scorched. Its size suggests a rocky surface, not a gas giant. And most importantly, it lies in the habitable zone, the sweet spot where liquid water could form. But Kepler didn't work alone. In recent years, NASA has launched its next-generation planet hunter, TESS, Transiting Exoplanet Survey Satellite, which scans the entire sky. Combined with ground-based telescopes and future missions like JWST and LUVOIR, we're no longer just finding planets. We're starting to understand their atmospheres, temperatures, and even chemical makeup. In other words, we're getting close. We're no longer blind. We're narrowing in on places that could truly resemble Earth.
But here's the catch: Kepler-442b is over 1,200 light-years away. We can't just fly there, at least not yet. So scientists are using every tool we have. The James Webb Space Telescope is scanning distant atmospheres for biosignatures. TESS is hunting for new candidates. And AI is now helping sort through massive data to find patterns we might miss. Every pixel, every spectrum, every anomaly could be the key to proving that Kepler-442b isn't just Earth-like, but truly alive.
Kepler-442b is almost perfect. It's rocky, just a bit larger than Earth, and it orbits in the habitable zone of its star, where temperatures could allow for liquid water. But it's still an alien world. A year there lasts just 112 days. Gravity would be stronger, your body would feel heavier. And its star, smaller and cooler than our sun, casting an orange glow instead of warm yellow light. If you stood on its surface, assuming you could breathe the air, the sky might look dimmer, almost twilight-like. Days and nights could be wildly different. And if there's life, it might not look anything like what we know. It's Earth-like, yes, but it's not Earth.
What if one day humanity actually made it?
After centuries of dreams, disasters, and relentless searching, we build a ship that can cross the stars. A generation vessel powered by technologies we once thought were science fiction. We leave behind a dying Earth, its skies choked, its oceans rising, its time almost up. We sleep for decades, maybe centuries. We drift in silence through interstellar space, and then we arrive. Kepler-442b, a planet orbiting a quiet orange star. It has the right size, the right temperature, the right light, blue oceans, rocky continents, breathable air. At least, that's what the probes say. And as our ship touches down and the first human sets foot on a new Earth, we ask ourselves, will this be our redemption? Or are we doomed to repeat the same story? Will we carve roads and cities into untouched wilderness? Will we mine, burn, consume until this planet too becomes a mirror of the one we left? Or can we change? Can we finally become not just explorers of the stars, but caretakers of what we find? NASA's search for Earth 2.0 isn't just about finding a planet. It's about testing who we are, what we're willing to leave behind, and what future we're ready to build. And the truth is, that future is being written right now. So if you want us to keep digging into the science, the missions, and the possibilities of interstellar travel, leave a comment below and subscribe. Because this story, the story of humanity leaving home, has only just begun.